Hello, my statistics dears. I'm just going to run through all the tests and show you what we are exactly looking at in terms of comparisons in all the statistics. So we'll start out with the first one, the Z-score, the Z-test, which is comparing a population. This is a known population. You can see this is all my known population. So you grab a sample, and now what you want to do in the Z-score, the Z-test, what you're doing is you're figuring out if this little sample that you have is representative of the big, larger sample that you have. Now, mind you, in this situation, you know the mean, you know the standard deviation from the population. However, if you don't have that, you don't know the details for the population, independent t-test might be better. When you're comparing two groups, you have two groups. Look, we have two different groups here of transportation vehicles. And what we want to do is see if this sample and this sample are from the same population. If they are the same, if it is not statistically significant, then we'll say sample 1 and sample 2 from the same population. If it turns out that our statistic is significant, then these are two different populations that are being represented. Two different populations. That's the independent t-test. Dependent t-test, it does the same statistical analysis, but it's the pre or post test. That's what I want you to focus on. Can it be matched samples? Absolutely. But it's a pre and post test. So you have a whole bunch of your things here. I got a train or two. I got a fire truck that's facing the wrong way. I got a boat. Okay. Here's what I want to know. I want to know if fuel efficiency or time to distance or whatever it is I'm concerned about, whatever I think might change with a thorough wash. So I measure it before, give it a thorough wash, and then I measure it after. But if you notice, it's the same vehicle here or the same people twice. That's why the degrees of freedom here are -2. It's because the same people. Make sense? Which is different than in an ANOVA. In an ANOVA, unlike the t-test where we have two groups, either the before and after group or this group versus this group, now we have a bunch of different groups. Like maybe we're looking at performance on different vehicles based on maybe who's the maintenance company, public, private, hybrid, public, private, self-care. That would make sense. Are we going to do, is there different, maybe we're going to group by color. Maybe is there different performances based on the color of the vehicle, because the color of the vehicle is related to, I don't know. But we have multiple different groups that we're trying to compare. See if this group is like this group, is like this group, is like this group. And if not, if there's a difference, if the statistic comes back, if the F comes back statistically significantly different, we got something going on. I wonder what it is. So that's the ANOVA. Multiple levels, one factor. Factorial ANOVA, multiple levels on two factors. So here, maybe we're trying to figure out if we have, what's the relationship between a high flow filter and how the cleanliness routine? Is there a relationship? So here, what we're doing, we have this group and this group, and then this group, and this group, and then this group, and then this group. So we have, you'll see we have 6 different groups because we need to cover all the conditions. So we have water only wash, high flow and low flow filters. We have water and soap wash, with a high flow and a low flow filter. We have water and wax with a high flow and a low flow filter. So we're looking at multiple different groups to see, is there any difference? Does it matter what we wash with? Does it matter what the flow is in terms of the filter? Do either matter? Does a combination of how it's washed and the air filter type, do those work together to create better fuel efficiency or whatever it is that you're worried about? That's the factorial ANOVA. You can see multiple different groups. It's getting more and more complicated. Now, correlation is about how things relate. So we can say vehicle preference and then the vehicle use. So is there a relationship between a person's preferred vehicle and the vehicle that they use? So this is what we would have here. This whole relationship. Is there a connection? Like someone says they prefer a fire truck, but they take a boat to work. Someone says they prefer a boat, but they take a fire truck to work. Someone says they prefer a train, but they take a plane. A boat, they say they prefer a boat, but they use a train. You know, car. That's the comparison we have going on. Would we be comparing words? No, that's more of a chi-square. But vehicle preference, 1 through 5, vehicle used, 1 through 5. We could figure out if there's a relationship between the vehicle preferred, favorite vehicle, and then the vehicle used. Is there a connection? And then we have our last buddies. We have chi-square. Remember, it's between observed and expected. So here we're just going to do the goodness of fit. We have 5 different types of vehicles we're looking at. We expect it to be evenly distributed in terms of finding in popular culture. So what we would do, let's see, we got a fire truck, we got a train, we got a bus, we got a plane, and another fire truck and a train, and we would go through. And the idea is to compare lots of fire trucks. Compare the percentages we actually see. If you'll notice, I'm starting to pile up a whole lot of buses. And now we got some cars coming in here. So are the percentages that we're breaking down here what's expected? Evenly, 20, 20, 20. Or is there a different setup? We got, well, if you'll notice here, I've got a lot of buses and a lot of fire trucks. Well, I got a lot of fire trucks. And you can see here, this would be compared. Look at all the percentages we observe, which are the vehicle counts we have here, to the expected, which is an even distribution, which is not independence. Independence, we want to see if 2 factors relate or not. But instead of actually looking at values, like in the correlation, we will be looking at 1, 2, 3, 4, 5. Here, the options are 1, 2, 3, 4, 5. Is there a connection in values? Here, we're doing something similar, but it's frequencies. So it's not a 1-to-1, or this is a 1 and a 3. That's not what we're looking at. What we're looking at is totals. These are comparing totals. So what we would need to do here is go through and like separate. We have primary color vehicles, secondary color vehicles, ones that use wheels to move, and one where wheels are not the primary. So we would have, those 2 would go there. Primary color with wheels, they're fire trucks. Here, primary with wheels would go there. With wheels, secondary, because these are secondary colors. Here, airplane, yeah, there's wheels, but that's not how they mostly get around. It's through the air, so that would be here because it's a primary color. Here's another airplane right there. We have some boats, a boat that's a primary color, a boat that's a secondary color. So we would take these totals, not like with correlation matchy-matchy. from the same vehicle, now we're doing frequencies. So that would be a chi-square test of independence. Does the color connect with wheels or not? But it's frequencies. And that's the basics of how the various statistical tests look at groups.